What's up, guys? Back at it on the lecture. I'm sure you felt right now you are materially pounded out. That's okay. Good news is this is the last lesson for this learning target, and since some of you guys are seniors, we're looking at the 15th, and then I'm not quite sure on the dates, but then we really only have a week or 2 weeks left. So we'll figure something out. This is kind of probably, if we got through this, I would say pretty good. So Richmond Friday, checkpoint, do those because that's for a grade. It's kind of make sure that you do your work. This stuff's not for a grade, it's just kind of for you to help learn. Wednesday is this catch up day. It's a district mandate now that we have a catch up day. And then we have our test probably Thursday, Friday. So into the last lesson. Nothing crazy new. We're just kind of combining our last Q lost, Q gained. It's we're going to combine parts A and part B to help us get there. Now you're going to need information from part A, which is basically the specific heats stuff, and then I just added that in there because you need it for one of your problems. And then from part B, you have this chart, right? During a phase change, okay, we use MH of F, or during when it's a vaporization, MH of V. On the temperature change, we use MCAT, all right? And that little graph helps us here. So the best way to describe this is Q lost is Q gained, okay? So this is your worksheet. When you are doing, I will set stuff up for you, but I'm going to have you crunch the numbers. When you're setting this up, we talk a lot about heat transfer as everything reaches equilibrium, right? Everything obtains like substantial temperature equilibrium. So like for example, when you heat your house, let's say your house is at 65 and your furnace comes on. Well, it takes a long time to heat your house because everything in the house has to warm up to that temperature. So like your couch, let's say your house is at 65 degrees. Well, your couch is cold, it's going to give off heat, or give off, it's going to take in heat as well, um, and vice versa. So it takes everything in your house then is at temperature, uh, per se. So for this, what we need to do is we need to set up our problem Q lost, Q gained. All right, so you got to figure out what is being lost and what is being gained. All right, and use MCAT. So essentially, what you're saying is you're saying negative MCAT is equal to positive MCAT. Okay, and with that, you might have multiples on each side. Okay, so let's just figure out what's being lost and what's being gained in each problem, and then you can set it up and it'll ask you to solve for what's what. All right, so a 400-gram horseshoe initially at 500 degrees Celsius is dropped into a bucket containing 20 kilograms of water. So the first thing right away is you need to make this into grams. 400,000 grams and 20,000 grams. Don't do it in kilograms. You'll get bad answers. At 22 degrees Celsius. Okay, so what's going to lose heat? Well, the Q lost is definitely going to be the iron, right? The iron is going to cool off, okay, the horseshoe. And then what's going to gain heat is the water, all right? So then how you set it up then is you say, okay, negative MCAT delta T is to positive MCAT delta T. All right. Now what that's going to allow us to do is that's going to allow us to say, okay, so we have negative 400,000 times C. The specific heat of iron, I believe, is 0.388. I might have wrote that wrong on the answer key. And then times the temperature final is what we want to look for. And it's at 500 degrees Celsius initial. And then the water is at 20,000 grams times 4.184. That's a specific heat of water, C, times temperature final. That's what we want to find, and it's at 22 degrees Celsius. Okay, so in the end, TF is X, okay? So you got to rearrange all this, do some serious algebra to solve for TF, okay? Now let's look at the next one. Q lost, Q gained. An unknown liquid of mass at 400 grams at a temp of 80 is poured into 400 grams of water at 40 degrees Celsius. Okay, so right away we know the Q unknown is the hotter item, so that's gonna lose heat, and then you're gonna have QH2O. And essentially what we're gonna solve for is the specific heat in the unknown. You're gonna solve for C, so that one's a little bit easier. Algebraically, you don't have to combine like terms. Okay, and then the next one, 200 kilogram or 200 gram block of copper initially at 20 degrees Celsius is dropped into 300 gram glass containing 400 grams of water, both at 27 degrees. Okay, so here the copper is the cold and this is the hot. All right, so the Q lost is equal to the Q gained. So what's losing heat is going to be the glass and the water. All right, so we're going to say negative QH2O plus negative Q glass. And that's equal to the Q of the copper. All right, so you have two MCATs on this side to solve for, and then we want to find TF. So that one gets real tricky because you got a lot of TFs and you got a lot of signage filtering and stuff like that. So that's that questions. All right, so now we get into our part B. We're going to combine our part B with this. So I have a glass of 850 grams of water at 22. I want to cool it down, and I want to add some ice with an initial temperature of 0 degrees Celsius. Find the final temp of the combination. The final temp of the combination is 8 degrees Celsius. How much ice did I add? So we're going to be solving for mass. All right, so we're going to have a Q lost is equal to Q gained. All right. Now, this gets a little tricky because there's water. All the ice essentially is going to be going to water. So see if you can set it up for a sec. Okay, so what we're saying is we're saying that, okay, so that we're going to say minus Q of the H2O because that's going to lose heat. This one is going to lose heat. All right, but what also you have to include is you're going to say since it's 8 degrees Celsius, that is going to be all liquid water, right? So we're going to have Q H2O plus the MHF. All right, so that's our old stuff from part B. All right, so you have to include that in there. Now, what you end up gonna do is you're gonna say, okay, minus MCAT, and then what you're gonna say is plus MCAT plus MHF. So what you end up doing is you end up solving for the mass, like, and that should be the same, okay? Because all this ice, it's going to take energy to make this ice into water, and then that water is going to go up to 8 degrees Celsius. So it's like you're melting it, and then you go up to 8 degrees Celsius, and you're stopping on that point. So if you remember our graph, okay, so that's where we are, right? You had ice at 0 degrees Celsius, you got to melt it, that's MHF, and then it's going up, so there's a temperature change there as well, okay? And then the other turn, so that's the other way is coming down, right, from 22. So that's where we meet on the graph. In other parts here, 350 grams of ice is at 0 degrees Celsius is added to 50 grams of steam at 140. Calculate the temperature. Okay, so now let's just think about this graph. All right, so here you are, right? You're at 140, super hot steam, and you're at 0, all right? And we want to find the temperature at equilibrium, okay? Now, what we can say is what's losing. So Q steam is going to be losing. What's going to be gaining is Q ice, okay? So that's kind of the gist how you set that up. You're going to have to figure out if you need to add. I promise you, you'll probably need to add Q ice and then plus MHF. HF, and then you'll also need to do Q vaporization. Okay, so check that out, check the answer key, and then this problem is the same as the one above. Okay, it's 15. These are definitely tougher problems. They take a little bit more thinking because you have to think about the slope and what we talked about in part B. These ones just take a little less. These ones take a little less thinking and setup, which these are the ones that'll kind of be on your test. These are kind of challenge problems. So, all right, guys, have a great weekend. Love you lots.